So, we will study the multi electron atom. Except this hydrogen atom or hydrogen like atom, means hydrogen or hydrogen like atom means is ion, basically say helium ion. Okay. It has 2 electron, but it's one electron is taken out. So, one electron is so it is basically ion, one electron has taken out. So, it is singly positive ions. So, for such system we have considered nucleus, okay. So, that is JD and outside only one electron, outside only one electron. So, what are the orbits or orbitals exist in the atom? So, there these electrons can revolve. Okay. So, that we have studied, there are different orbits. So, that we have seen n equal to 1, okay. So, L equal to 0, okay. So, that is this we tell K shell, n equal to 1 K shell, and S L equal to 0 S orbit. So, this we tell this gives K shell or K orbit, K shell, and this corresponding L equal to 0, this S orbit or subcell, right. So, this say it is n equal to 1, it is 1, n equal to 2. Then this we are telling L cell and corresponding L equal to 0 and L equal to 1. Okay. So, this it has S subcell, S and P subcell or orbitals, L orbit, P and S orbitals. So, similarly for n equal to 3, we have seen L KLM, M shell, and corresponding L equal to 0, L equal to 1, L equal to 2. So, SPD subcell, right. So, similarly n equal to 4 you will get n equal to 4, you will get this is N shell, and here you will get S, P, D and F, right. So, then we have seen that, so electron can be, so here basically it has 2 subcell. It is not 1, it is basically 2. Okay. Similarly, so it is not circular, it is elliptical shape. S will be when n equal to this for all S orbitals, that will be the spherical, otherwise all P, D, F they are not spherical, elliptical. Okay. So, now one electron having 2 angular momentum L and S. So, all the time in this case S equal to half, for all cases S equal to half. Okay. And now we have seen when it is quantized in space for L value. So, this quantized in space, that gives ml value, this gives ml value. Okay. So, that ml is basically minus plus L to minus L, plus L to minus L, in between 0 will be there. Okay. So, it gives 2L plus 1 number of ml value, and for S half it will have two space quantization for spin angular momentum. There will be two space quantization, one is plus half and another minus half. Plus half, it is parallel to the fixed direction in space, and minus half, it is anti-parallel to the fixed direction. Okay. So, for S we will get ms plus half or minus half, plus half or minus half. Okay. So, this electron, wherever it is, it will have. So, we can specify the electron with this quantum number, So, to specify this, we consider what is its n value, and then what is its L value, then what is its ml value and ms value. Okay. This 4 quantum number, using this 4 quantum number, we can specify the state of electron where it is. So, it can be anywhere, it can be there are many cells, orbitals, it can be anywhere. So, to specify that one, we take this 4 quantum number. When we do not consider the coupling, LS coupling, there this quantum, this angular momentum, they are independent. We consider that they are not coupled. Okay. So, when we consider they are coupled, then scenario is different. Okay. So, for one electron, what are the states we can get? It can be n equal to 1, L equal to 0, L equal to then 0, then ml is 0 and ms can be plus half or minus half. It can be, for this case, it can be plus half or minus half. Okay. So, either plus half or minus half. Okay. That one has to consider. So, corresponding basically S is half, its spin is half. So, when its spin is half, so it can have two states, plus half or minus half, right. Now, when we consider coupling, so as I mentioned that we use the vector model, how they are coupled, how to find out. So, we use the vector model, vector addition, basically it is called vector model, very useful model. vector model. Okay. So, using the vector model, one can get the resultant, basically angular momentum. So I have electron. So it has angular momentums. Okay. That means electron is rotating like this. So its angular momentum L is say this. Okay. L is this, and then it has also spin angular momentum. So its spin is also the spin is say in this direction. Okay. Or it can be yes. So now L and S, it is vector, it has magnitude as well as direction. Okay. So if you add them, so just vectorial rules one use. Okay. If it is L, if it is S, then this will be J. So their resultant is J. So that I have discussed. So here when they are aligned, so obviously there will be, their magnitude will be just simply it will be added in same direction, since they are in same direction. So J plus S, whatever L value plus S. Okay. And if another extreme case, it can be just in opposite direction, S is just anti-parallel to this L. So in that case it will be L minus S, magnitude will be just L minus S, right. And other value depending on their angle, if angle between L and S is not 0, when it is 0, so the magnitude will be L plus S, and when they are anti-parallel, okay, so magnitude will be L minus S. Then it is 180 degree, basically angle between these two 180 degree. For other cases, depending on angle, you will get the resultant. So that resultant is one will get from vectorial addition. So L plus S minus 1, L plus S minus 2, etc. So up to L minus S. Okay. So that hopefully I mentioned in earlier class. Okay. So this basically is the J value, this will give the J value, and corresponding resultant it will have direction also, but this is the magnitude, these are the magnitudes of L value. So L plus S to L minus S, so that is the J value, and this is basically called LS coupling, LS coupling. Okay. So now in case of multi-electron, this concept is extended. Now if I have two electron, so then what will happen? In case of two electron, say helium, it has two electrons. Now two electron, each electron is having its own angular momentum, either orbital angular momentum or spin angular momentum. Okay. Each electron will have its own angular momentum, orbital and spin angular momentum. So now I can write So, helium I have taken as an example, it has 2 electron, okay. But if I take, I will show you that there is a difference between that helium 2 electron and any system having 2 electron. So, that I will tell you later on, equivalent electron and non-equivalent electron. So, I will come to this point later on. Just let me, in general, let me tell that now multi electron. So, now if I consider 2 electron system. So, each electron have its own angular momentum, orbital angular momentum and spin angular momentum. So, what I can do? So, it is whatever it has some n value. So, n1 for electron 1, n1 equal to say 1, L1 equal to, obviously it is 0. If n is 1, L will be 0. So, now whatever n, L, ml, ms. So, now I am writing for first electron as a 1 L1. So, then obviously S1 equal to half, okay, of this electron. Then you have ms1 will be plus minus half and ml1 it will be 0. So, I think this I will not write now, let me come up to this. So, what I want to find out this using the vector model, what will be the J value, okay, right. For 2 electron system, for 1 electron system, what will be the J value, that I have shown you how to calculate. Now, for 2 electron system, what will be the, so n equal to say it is also 1. So, L2 okay. So, L2 it can be if it is N2 equal to 1. So, it is basically N1 equal to N2. Okay. So, now L2 equal to here, if I take 1 then it is 0. So, but in principle that electron it can take any value it can take any value of n. So, I will not write n equal to 1, it can take any, another one can take any value of n. So, I will not write. So, this for electron 1 and this for electron 2, second electron. So, it can take any value of L1, other one L2, say S1. So, it is half of course. So, let me not mention, its spin is half and this other one spin is S half. Okay. Now, I have 2 electron. So, it has L value, it has S value. Okay. So, it is L1, S1. Okay. Another I have another electron, it has a L2 and it has a S2. Okay. Now, 2 electron in one atom, it has one nucleus and 2 electrons in the system. So, now so now coupling we have seen, for single electron coupling we have seen LS coupling, okay, L and S. So, this electron also have L and S. So, I can get J1, resultant I can get J1, right, I can get J1, this one will be J1, and this one will be J2, this one will be J2, okay. This one, say let me write here J1, okay. So, this is one possibility, that one electron, so they couple this, that electrons angular momentum, spin and orbital angular momentum, they coupled and get the resultant angular momentum, that is J1. And for other one also, okay, its own, this electron its own angular momentum, spin and orbital angular momentum, they coupled and form the resultant angular momentum J1 and J2. Now, J1 and J2, so one is having say this direction J1 and another is having say this direction J2. So, this is J2 and this is J1. It is in same atom, it is in same atom. Now, two angular momentum, result angular momentum J1 and J2. Okay. Now, it may happen that they will again interact and give the resultant momentum. So, that one can get adding this vectorial addition of these two. So, this and this, so this can be this, okay. This can be this. So, this will be the resultant J, this will be the resultant J. Okay. So, vectorial addition to this J, it can take value J1 plus J2 to J1 minus J2, okay, magnitude. Let us take magnitude. Okay. Okay. So, this type of, in multi-electron system, this type of coupling is called JJ coupling. This type of coupling is called JJ coupling. JJ coupling. Okay. So, this is one possibility, coupling of angular momentum of two electrons. Here I have shown. If 3 electrons, 4 electrons, what will be the case? So, one has to find out, in this case for JJ coupling, one has to find out J1 for 1 electron, second electron J2, third electron J3, J4, J5, etc. right. And then I will take the vectorial sum of J1, J2, then whatever the resultant I will get, then I will add with it that J3 I will add, right, vectorial addition, then whatever the resultant J4 I have to add. So, that way vectorial sum addition one can do and get the resultant J of this multi electron atom. Okay. Similarly, other case may happen that before, instead of LS coupling in individual electron, it may happen that 2 electrons are there. Now, their orbital angular momentum is coupled. Okay. So, that means L1 and L2, L1 and say L1 and L2 are coupled, vectorial sum you can get. So, you will get L. So, let me write with capital letter. Okay. So, now that is the resultant L of the angular momentum of the 2 electron system, and spin S1 and S2, they are coupled, spin angular momentum is coupled. So, this one and say this one. So, S1 and S2 they are coupled. So, you will get the resultant S, capital S, right. Now, 2 electron system, now its total angular momentum L, capital L, total spin momentum capital S, total spin angular momentum capital S. Now they will, now this resultant L and resultant S, they, if they coupled, then I will get J, resultant J. So here if it is L, okay, if it is L, this L direct L, and then if it is S, okay, capital S, then I will get the resultant, say this one. So, I will get resultant angular momentum, that is J, capital J. Okay. So, now the J, capital J, this what will be the capital, so here what will be the L value? So, vectorial sum, vectorial addition, L like similar way one can write capital L, that will be, that magnitude of that will be basically L1 plus L2 to L1 minus L2 magnitude. Okay. Similarly, for S, capital S, okay, magnitude will be S1 minus S1 plus S2 to S1 plus S2, S1 minus S2, okay, S1 minus S2. Similarly, here for J, vectorial sum, the same way one can tell that J will be capital J, J will be magnitude of this will be, it is the L and S. So, L plus S to L minus S. Okay. So, this called basically this called LS coupling, this called LS coupling. Okay. So, here I showed you that is JJ coupling, and then other one this way, if its resultant J, if we get this way, here also you are getting J, resultant J, other case also you are getting resultant J. So, if you get this way, so then it is called LS coupling. So, then it will be called LS coupling. So, both are possible in multi-electron system, but in one electron system there is no question of JJ coupling and LS coupling in that sense. Okay. But this term, these are basically useful for multi-electron system, JJ coupling and LS coupling. What is JJ coupling, that I explained, what is LS coupling, that also I explained. Now, most of the atom shows the LS coupling, most of the atom, multi-electron atom shows the LS coupling. Only heavier atom, Z value is very high, only few heavier atoms, they shows the JJ coupling. Okay. They shows the JJ coupling. So, that is why mainly we will concentrate on this LS coupling, not JJ coupling. Okay. So, this is the basically vector model. So, we have considered 2 electron. So, if 3 electron, 4 electron, 5 electron, so same way one can find out. So, this is for L is 2 electron. So, if I take third electron, so this L3 I have to add with this L, okay, then I will get the resultant L. Similarly, S, and then we will get J for 3 electron system, 4 electron system, 5 electron system. Okay. So, I think I will stop here and then I will continue next class. Thank you.